One question that I get asked the most is I have a MacBook with 8 GBs of RAM, and what is the best model that I can run on it locally? Well, I came across this open source tool that allows you to run Gemma 4 26B variant in under 2 GBs of RAM. Yes. So we will be testing that claim and we will be testing how much is the speed, and I'll show you everything that you need to get started, and you can just follow this video step by step along with me. So by the end of this, you will have it running on your machine locally. So without any further ado, let's jump straight into it. This is that open source repo called TurboFieldfare that allows you to run Gemma 4 26p A4B model under 2 GBs of RAM on any M series MacBook. And this repo is currently at 5,500 stars. If you had an old Mac thinking that it might not be useful, that is the best pick for this experiment. I'll put the YouTube link in the description of the video so you can follow along. So just to give you some context about this Gemma 4 model. So generally this Gemma 4 26p variant, this is a mixture of experts model. What I mean by that is it is having these 26 billion parameters, but at any point of time, only 4 billion parameters are activated. So even if you see the Q4, which is the Q4 quantization, it requires at least 14 GBs of RAM, and the 8-bit requires 28, and so on. So you would be able to load this into your memory if you had 16 GBs of RAM, the Q4 version. And the repo is claiming that you can run the Gemma 4, this model, under 2 GBs of RAM. So that's the claim that we're going to be testing out today. Now let us talk about how you can actually use TurboFieldfare. So there are three ways. The first is via the native Mac app. The second is through a command line interface. And the third one is it provides you an OpenAI compatible server that you can run. So these are the three ways. And all of this use the same model. What that means is at one point of time, we can run only one product. And I wanted to share my machine's configuration. So I would be running this on a M4 Pro with 48 GBs of RAM. I'm so excited to test this out. So let's jump straight into it. So we will follow these instructions. We will copy this. So here I'm on my terminal. The first step is to clone the repo. So the repo has been cloned. Next, we will go into the folder that got created, Turbo Fieldfare, and then we have to run this command. As you can see, all the Swift packages that are required are being downloaded and then being built here. The build just got completed. Next up, we will run this command. And what this will do is it will open the Mac app. So this is the Mac app, and it says that it requires 15 GBs of storage to download the 4-bit model. So let's click on download. Currently, 2% download has been done. I will be back once the model is downloaded. We will resume from there. The model has been downloaded. Let me take you guys back to the app. So here we are on the app. You can see the model has been installed, but it's currently not being loaded. And to start, we can click on this load model button. On the right, you can see different configurations. The Gemma 4 26B model, it says it's ready. So let us start with giving a prompt here. So we will say, help me understand what do you mean by large language models. So it has given us a response. At the top, you can see the token per second, which is 28.8. And the memory it is taking is actually 2 GB, which was the claim in the repo. So from the memory aspect, it seems accurate. And if you see the response, it says a LLM can be broken into three terms, which are large language and model. And then it talks about each of these terms independently. And it talks about how does it work, and the secret sauce, which is the transformer. So that's the response that we got. One thing that I want to share with you all is that in general, this Gemma 4 26B model is a multimodal model, so it accepts images along with text. But if we are running this via Turbo Fieldfare, then it's a text-only model. There's no way I can give it images. I help founders and individuals in leveraging AI. If you are somebody who's trying to figure out how AI can benefit you for your individual use case, or let's say for your business, then drop me an email with details of what you're building, and you can find my email in the description of the video. So this is one way how we can use TurboFieldfare using the Mac app. Now let's see how we can actually use the CLI. For this, we will go back to the README again. So the CLI uses the existing model folder that we already talked about. And in our case, we have already installed the model. So we don't have to do this step. What we can do is we can instead verify the existing installation without loading the model. So let me copy this. As you can see here, the verification was done. If you want to see what all options are there and the full complete list, then you can do this via the help command. So here you see Swift run dash C release, the CLI release dash dash help, and then it tells you the usage, like how you should use this CLI. And this is how you can pass in the prompt or you can give in the messages file the way we have done. So the model is required, and out of these two, one parameter is required. And all these options that you see are the ones that you can play around with. You can set the maximum generated token limit, the context limit, and various other things that are given here. Now, what we are going to do is I will show you a sample of how to use the command line interface. So for that, we'll first create a JSON file. Let's do that. Touch messages.json. And in this JSON file, there will be a JSON array with role as user. And this is the content. Let's save this file. And now let's run it. So you see we are using Swift run this CLI release. And this is the message. This was the exact JSON file that we created. And here's the output. It says to understand why chunked prefill is a breakthrough in LLM service, we need to understand the problem and various other things. This is the output here. And at the end, it gives you the stats that we were able to see in the Mac app. The third and the last way is through the OpenAI-compatible server that you can run. It exposes an endpoint that you can use for chart completions, function tooling, and various other things. And you can plug that endpoint into OpenCode. The whole setup is mentioned in the README and the repo. Do check that out if you're interested in that one. But in this demo, I won't be going into the details of it. If required, let me know in the comments below. Another thing that matters when we are running models locally is called tokens per second. And if you see here on a 8 GB M2 MacBook Air, the token per second is between 5.1 to 6.3. And on a 24 GB M5 Pro, the token count is from 31 to 35 tokens per second. And if you want to run this, there's one more thing that you need to ensure that you need to be on Mac OS 26. So if you're running an older version, just upgrade your Mac before starting with this. Let's take a look at these community reports also. So here you see all the community benchmarks. These are the results that are submitted by users like us. And here you can see people have given in different configurations. They tried to run it on MacBook Neo, Air, and you can also see the prompt length and the generated tokens along with token per second. You can see in for different Macs out there. So this is basically a good place for you to refer to know what the stats would be like. So with this, we come to an end of the video. If you are somebody who is having a M series MacBook, I would highly recommend you guys to try this out, especially if you're the ones who are having the 8 GBs of RAM. Do try this out. Let me know in the comments below your experience with it. I would love to hear from you. If you are viewing this, I would love for you to subscribe to my channel and share it with your friends. It will help the algorithm to be boosted, and it will help my small channel in reaching more people out there. So make sure you like, comment, and subscribe to my channel. I'll see you in the next one. Bye bye.